So yeah, as I was talking about, right, Goroutines as cognitive tests. Couple of you have done Golang here. Anyone who has used, let's say, Kotlin? Kotlin, folks, no? No one from Android in here? Yeah, like they are sitting in different hall. Okay. So Kotlin has a very close relation with Goroutines. But anyway, let's get started. So hi, Anubhav Singh, co-founder Callchimp.ai. A couple of other things, if you're interested in any of them, we'll talk about those. And let's get to the main thing, right? Cogito ergo sum. How many of you have heard of this? Yes, 1, 2, 3. You're like this again? No? Okay. Properly heard of it? Properly you have heard of it? Yeah. What does it mean? Sorry? I think therefore I am. What is happening? So cogito ergo sum was given to humanity by this guy. Right? Do you recognize? Descartes. Mr. Descartes, right? So he gave us the philosophy of cogito ergo sum. And how many of you have heard of him by any chance? You have heard of him? Yes? How many of you have not heard of him? Yeah, they are very confident. They are like, I have not heard of it. Why are you even asking? Yeah. So this guy is known as the father of modern philosophy. How many of you are born after 2000? Yes? So this guy is known as the father of philosophy. Is that a surprise to you? Not this guy? Yeah, but anyway, Mr. Descartes was famous for giving a lot of philosophies. Actually, he worked in a lot of fields of mathematics and coordinate geometry. Do you remember? Class 10, class 11, coordinate geometry. How many of you did that? Yes. What is his relationship with him? With that? Cartesian algebra. Right? This guy was the person who introduced the Cartesian and the algebra mixture, which you had to study in class 10. Not this, the earlier one. This one, the actual one, right? Father of philosophy. Right? So this is what he's mostly famous for. But then he gave us this very nice statement, cogito ergo sum. I think, therefore I am. Right? I think, therefore I am. How many of you agree with this? Yes? How many of you disagree with this? No one? Yes? You were trying to disagree? You were like, okay. Anyone else? You disagree with this particular philosophy? No? It does not matter. He doesn't care. He's dead. Right? But then, the way we think. How many of you have heard of Anubhav Singh Bassi? He is my nemesis. Yes? This guy. Right? So whenever you are copying code, you're like, we are probably doing something wrong, right? This is how humans think, right? We have a way of thinking, and that thought changes. It's not necessary that we think the same thing. Based on the inputs that we are getting, based on the feedbacks that we are receiving, that thought might change, right? Initially, when you are going to copy code, you are like, probably I am doing something wrong. When you're, just starting out. And then that code works, right? That code works. And then you're like, are we doing something wrong? What we are doing, is that wrong? Is that actually wrong? Is copying code wrong? Right? That is the kind of thought we have then. And then based on other input that we are receiving, right? We keep receiving new input, we keep receiving feedback. Based on what input we are receiving, we might change that thought midway. Right? What even is the concept of wrong? What is wrong? What is right? Everything is wrong and right. Isn't that how humans are? Isn't that how we think? Right? Before doing something wrong, before stealing money, how many of you have done that? No? Yeah, before stealing money, we all think that, this is wrong, we should not do it, it's a crime. But then once you start doing it, then you are like, let me figure out how to get it executed properly. I should not be caught. If I get caught, then it's stealing. Right? And when you have done it, then you're like, it wasn't a crime, I was just taking it for my needs, I really had some needs. Right? If I use that to fulfill those needs, why is it a crime? Right? So this is how humans think. This is how our thoughts change while we are getting input, while things are happening. Right? And another factor which impacts this is while you are doing things, you are actually thinking about it. Right? You are continuously taking in feedback. You are continuously taking in some sort of input. Right? People who just came into the hall. Right? While you were coming to the hall, you had a different mindset. Right? You were like, where is this hall? What is happening there? You came to the hall, you entered, and you saw that I was already speaking. And immediately in your mind, it was like, oh, the speaker is already speaking. Let me just quickly grab a seat and, be seated. Isn't that what happened? Right? So based on whatever inputs we are getting, we always keep on, evaluating what we are doing, what we are thinking. And this is in a way multitasking, right? Multitasking, you are walking, you're also thinking, and you're also looking for a seat, right? All these different things, this is what a human does actually. Almost all of us, we love multitasking, right? And before I come to multitasking, I do have a question though. What is cognition? What do you understand by cognition? Right? Replicating human behavior using Go. What is cognition? Has anyone thought about this? Comprehending things. Natural intelligence. Natural intelligence, okay. Anything else? Anyone? Gave a thought about this? You might be like, ye kya arts ka class chal raha hai, right? What is this arts class? Right, so, humanities we are studying. But anyway, what is cognition? We have got two answers. Anyway, let's look at the dictionary definition, right? Cognition is defined as mental action or process of acquiring knowledge, right? What is knowledge? Whatever you are seeing, you're getting as an input, you're processing it, that is knowledge, right? It could be knowledge about the things that you study from a book. It could be knowledge about the world around you. You open your eyes after waking up and you see the world around you. That is knowledge, right? What is going on right now? Understanding through thought, experience, and senses. Through thought, experience, and senses, right? Based on your experience in the past, please don't fall. Yeah. Based on your experience in the past, the same input given to you might have a different meaning. Do you agree with that? Right? Someone comes up to you in a random public place and tells that, hey, please hand me over your phone. I'll make an emergency call to my family. Right? My phone is dead. Now, if you are someone who has never been in this situation before, you're probably likely to give him the phone. But if someone has duped you in the past using this technique, you're not likely to give him the phone. You'll be very skeptical, right? So that is what cognition does for us. Cognition is basically based on inputs coming in. Yes, one, inputs is not the only thing. History, right? What history we have with that particular input also matters, right? And then obviously the senses, the way we see things, hear things, we can probably touch objects and understand what those are. So that is another way of getting input. And if we translate it to machines, we'll come to that later. And let me talk about multitasking. Just a quick example, I think all of us understand what multitasking is. Something like this, right? Pretty much every morning. How many of you? The people don't think on the toilet these days. Don't you agree? We don't think there. We take a phone and we're like, social media and everything. But then obviously some of us are smart, so we are also like this. We can also take input from multiple sources at the same time. There are two people talking to you in a friend circle of three people, friend triangle of three people. When there are two people talking to you, you're listening to both of them rant about life and you are able to understand. Right? This happens. Three friends. Right? Is this multitasking? How many of you said this is multitasking? Have you seen this movie scene by any chance? Yes, some of you. This is probably, all of these memes and these anecdotes, all of them are mostly from North Indian movies. So I'm not sure how many of you have seen them. But in this scene, what is supposed to be happening is that someone is firing on this guy and he's hiding behind a cycle and he is firing back. Right? That's quite some protection we have. So is this multitasking? I would say no. And I do have reason. I have very, very strong reason to say that. There's a link. If you open that link, you will see a calculation which I've done using Gemini, which tells me that this guy is only 5% covered by the cycle. Right? So, yeah, definitely not multitasking. You can click that link. You don't have to really type that down. You can click this link when I share the deck with you at the end of this talk. So anyway, let's move forward, right? Not multitasking, right? Goroutines. Why am I going to be talking about Goroutines? Please be seated. There's some seats here. Goroutines. How many of you have heard of Goroutines before? Goroutines before. Raise your hand high. Yes, that is what we want. Yes, 2, 3, 4, 5, 6. Awesome. How many of you have heard of asynchronous programming? Async programming. Yes, more people are aware of this because you have probably worked with async, await in Node.js, JavaScript, TypeScript, those kind of projects. Anyone worked with async in Python by any chance? Async in Python, what were you doing? Calling APIs, async APIs, okay? APIs which were slow, right? What were you doing? Similar? Discord bot? Yeah, you definitely need async, yes. Yeah, so async is a programming paradigm in which you go ahead and get things done, not really waiting for a response to come back. Sometimes you might, and while you are waiting, you keep the execution flowing. The program execution keeps going on. However, the async things runs in a single thread, right? How many of you are aware of the concept of threads? Threads, not the social media app. If you're thinking about the social media app, hands down. Yeah? Few of you? Okay. How many of you studied operating system in your college? And now since the audience has changed a lot, how many of you are students? Raise your hand very high. Okay, students came late, as usual. Yeah, people who are going to offices, you know that you cannot afford being late. Yeah, but students can. Anyway, if you're studying operating system, you know the concept of threads, right? So there are CPUs, right, the central processing unit, and the CPUs handle a lot of threads. There could be various techniques in which these threads are handled. It could be, let's say, they are executing those threads on round-robin fashion. If you have four threads running, you're like 1, 2, 3, 4. Once the execution is done, you repeat the cycle, right? This is the easiest way to do it. The other being weighted round robin. You're like 1, 2, 3, 4 done. Now, which one is asking for the highest priority? Then I go to that person, and then again, you start on with the round robin. Right. So, when I say async await, all of this runs on a single thread. What does that mean? If I have, let's say, my task is, you might, have you ever worked with cron jobs by any chance? Cron jobs? Do you understand cron jobs? Yes. These are basically, for those of you who have not heard of cron jobs are basically time-triggered events, right? So on your system, probably a function needs to run every 1 minute, every 5 minutes. Maybe, for example, if you're using, let's say if you're using any of your banking apps, if your bank sends you a statement every month, right? Usually you get an email statement at the end of the month saying, hey, this is what you did in the last month. This is a cron job which is being triggered every month. Please feel free to sit here. There's a lot of seats. Yeah. Students, are you students by any chance? No? Then why are you looking for the last bench? Okay, where was I? Cron jobs, yeah. Cron job triggers, right? So if you have a lot of cron jobs running, right? So an alternative to running these cron jobs from the system is to use a service like a scheduler, right? You can probably create a scheduler which is supposed to be triggering a lot of jobs, right? It's probably a simple web app running on one server whose only task is to inform other programs about the time, right? So it's a scheduler service. Every 1 minute, it will hit a given set of APIs. Now, if you have, let's say, 1,000 APIs to hit, 1,000 APIs to hit, right? What are these APIs? Let's say you have 1,000 bank customers and you want to send them an email about their monthly statement at the end of the month, right? So the moment it is midnight of the last day of the month, you want to send them all an email saying this is what you did in the last month, right? Now, if you have 1,000 customers, how much time will it take to complete sending an email to all of them? Let's say if sending every email takes 1 second, although it is not, it's like more like 3-4 seconds. But sending an email takes 1 second. How much time is it going to take? 1,000 seconds? 1,000 seconds? Not really. We know that. That does not happen. When you are using async await, you can probably get it done faster, right? How much faster? How much faster? Yes? Based on the capacity of the machine. Wow, you're already talking about the capacity of the machine. So that is one point we'll keep in mind. Capacity of the machine is under consideration. Anything else? Sorry? Number of instances running. Very interesting. That's a different way of dividing the problem. You don't send out emails from the same server. You have multiple instances running to send out the emails. You hit all of them, and then they send out the emails. That is one solution, definitely. That's really good. Anything else? Sorry? Use thread creation. Minimizing the new thread creation. Interesting. Why would you minimize the new thread creation? Mm-hmm. Sorry? But why would you want to decrease the number of threads you are using? Why can't you just have 1,000 threads and run it all together? CPU can run 5 or 10, that's what he's saying. Is that a problem?
No. I mean, we can configure
5 or 10
that.
actually depends on how big the thread is, right?
I mean, that is a configurable.
Yeah.
We can getting the number of thread is experimentation, right? We cannot claim we have to use.
I mean, if your thread is lightweight enough, it's probably just sending out an email, just an API request. It's probably very, very lightweight, right? It's not going to be heavy. If you are probably, in every thread you were loading a small SLM, then you would run out in like 2 threads.
Correct. Yeah.
Right? So,
I mean, mainly context switching kills the performance also. So that is the point I thought to share.
definitely. I mean, if you're switching the context, in this case, I don't think we are switching the context much. I mean, you're just saying this is the task, get it done. That's all, right? So, but then yes, why would you minimize the number of threads you're running? Mm-hmm. Okay, but when you are using async await, so there's a small issue which you need to keep in mind, right? When you're using async await, it will take certain amount of time, right? And then when all the awaits complete, you will get a lot of jumbled response at the same time, right? So all of this is actually going to become slightly heavy on your application, right? But if you were able to run very, very lightweight threads, right? For example, you said you want to minimize the number of threads. I am saying, let's make 1,000 threads. And that might be a better solution because 1,000 threads, if your machine can support it, then that's great, right? But what happens, which he also mentioned, is that the CPU can handle only a limited number of threads at a time, right? Only a limited number of threads at a time because threads can tend to be heavy, right? But at the same time, if you're running multiple threads on CPUs, let's say there are 4 threads which are running on a single CPU. Not all of them will execute at the same time, right? Thread by thread. First, the time is allocated to the first thread, then the second thread, as I mentioned, right? Round robin or whatever fashion you want it to be. Let's, not make it complicated. Let's just go with round robin. Goroutines, on the other hand, are actually very, very lightweight threads which are not managed by the CPU. Right? So what are these threads? These threads are created by the Go runtime itself. The CPU is there, the Go runtime runs on that particular CPU, and the Go runtime maintains the threads. Right? So the programming language itself is taking care of creating threads and executing them. Right? And what helps Goroutine in this is that these are extremely lightweight. How lightweight? Somewhere towards the tune of, let's say, having a 4 KB Goroutine is actually a decent size, right? So if you had 4 KB of Go routine, you could probably run like 1,000 of them in what, 4 MB of memory, right? So 1,000 threads, why not? Let's do that. 100,000, yes please, right? 40 MB, that's all. Right, so hitting out an email is probably even less than that. It's not 4 KB. It's probably somewhere close to 2-3 KBs actually. So you could have a lot of these threads and you could send out all those 1,000 or maybe 100,000 or even more than that at the same 00 time within the 3 seconds which it takes to send out that email. Right? So that is what Goroutine can do for you. It allows you to have these virtual threads, let's call them virtual threads, which are running and maintained by the Go runtime. And then these are extremely lightweight. So that's good, right? The CPU core, the system thread, and the system thread has Go runtime running, and Go runtime has all these runnable Go routines, which is like maintained by Go runtime. That's okay. But let's say we have these, like sending out an email is actually an easier task, yes. But what if we have a much more complex task, right? What if we have a more complex task which requires inter-thread communication, right? Inter-thread communication. What could be a task like that? Say, for example, you have 100,000 websites to crawl, right? Think about this very clearly, right? Think about this and try to map it in your mind while I say this. You have 100,000 websites to crawl. You probably start from wikipedia.com. A great starting point for anyone who has been in web crawling and tried making a search engine. You know that Wikipedia is a great place to start for web crawling, right? Similar structure everywhere. A lot of links. The links are almost always working. If they are not, they are marked that this is not working. So it makes your life easier as a crawler. You have 100,000 websites to crawl. Starting off from wikipedia.com, you start reading through the pages one by one. Now there might be a page, which probably the 3rd or 4th page we encounter, which leads us to, let's say, the website of Microsoft, right? You go to microsoft.com. And probably the 5th or 6th page leads us to the link of, let's say, google.com, right? Somewhere in Microsoft, you are reading about some research which is about LLMs. Within LLM research, you come across the paper, Transformers is all you need. You understand that paper? That was probably the starting point of the whole LLM thing, right? So you go to Transformers is all you need, and in that paper, you get a link back to Google, right? Because Google researchers were involved in that. So you get a link back to Google, but then you have already started crawling Google before on the 5th page. And from Microsoft to LLMs, then Transformers is all you need, and then back to Google, right? Probably on the 9th or 10th step down the tree, right? You're creating a tree by crawling, right? So on the 9th leaf of the tree, it tells you to go back to google.com. But since you have already started crawling it on the 5th step, why would you do that? Do you want to go back to google.com? Do you want to recrawl it? It's a huge effort. Google is huge, right? So you would want to avoid that, right? You want your crawler to say that, hey, we have already encountered this. Let's not do it. But if you create multiple threads and all of them are busy crawling, they will simply crawl the same thing probably like dozens or maybe like hundreds or thousands of times, right? Maybe a website which is highly linked by a lot of pages, for example, github.com, right? A lot of pages out there, the readmes that we see of a lot of documentations of tools, pretty much everyone links back to GitHub, right? We will be probably spending half our time just crawling GitHub every time. Does not make sense, right? So whatever threads you are creating, let's say you have created a lot of Go routines which are doing the crawling. You have created these, let's say the same crawler like agentic application, which just goes down and keeps crawling web pages. And it finds links and then again goes back and keeps scrolling them, right? So what your thread needs to do is it needs to communicate. One thread should be able to ask the others, have we already covered this website? Have we already covered this particular link? Right? Could be a single blog. Maybe if you take a look at blogs like Analytics Vidya or Machine Learning Mastery, right? So they have tons of blogs, and you don't want to crawl all of them multiple times. Their content is not changing, right? It's not changing every day. So your threads need to communicate. Now there are multiple ways to do this. For people who are already thinking about this problem, you know that this can be solved in n number of ways, right? You can skin the cat in many different ways. You can probably store things on a database, as simple as that. Probably structural or like document database, totally up to you. You could store it there, and the other threads can always query it. Is this link already done? And the others will say, yes, it's done, don't worry, we have handled it, right? So this is something which you can do. What is the other thing which you can do? A thread asks another thread, hey, I've already done this. It keeps informing everyone, I've already done this, and you don't need to do it, right? So this is another way that the thread can communicate with each other. Channels is that tool, right? So whenever threads are telling other threads about what they have done, what variable they have produced or changed or updated, you can always use channels to do that communication. Now the interesting thing about channels is that it's always first in, first out, right? It's in the shape of a pipe. And whatever input you are giving, it will keep on traveling till it reaches the other Goroutine. Let's call it a thread for now. It reaches the other thread. The first value that you put in will always reach first. What does this tell us? For example, there's a variable counter. Let's say a simple variable counter, right? And all the threads are supposed to keep maintaining and updating the counter, right? So we can create counter as a variable, a channel variable, and all the threads will have access to increment it, right? If they just keep sending numbers, it will be a problem. Like all of the threads, all our 1,000 threads, they started at 0. And all of us, like all of those threads, whenever they execute a website, they crawl a website, they reply back with the count of number of websites that they have crawled. Is that a good idea? No. Why? Because all these threads will probably be somewhere around 1, almost at the same time, 2 almost at the same time. Probably once they're down like 20 or 30, there will be a lot of discrepancy. Someone is at 15, someone is at 25. It could be. But then, if you do need to maintain that counter of how many sites have been crawled, you need to get these threads to tell you increment. That's all. They all send in the channel, the same channel, that, increment. And you keep receiving that channel at a place, and whenever you get an increment, you just up the value. You understand what's happening here? They are not telling me which number to put. They are just telling me increment. Whatever you have, just add it by 1. So if thousands of threads keep sending me an increment at the same time, I will be able to consistently keep updating the number without losing track, right? I will not have the wrong number at any point. And this is what channel enables us to do. Channel is like a pipe in which you can send information. So you need to think slightly different while you are using channels. You don't always send the exact value every time unless that's what you're using. Otherwise, you can send modifiers. In the particular channel, you can always send modifiers which change the value there based on whatever rule is going to be applied, right? So there are obviously a lot of Golang folks who are here in the room. You understand that whenever you have channels, you also have an operation of taking a sync, and then based on that, you just add conditions and you execute things. But we'll not go there. For now, let us just understand that a channel allows communication between 2 threads, right? You can have multiple threads, and all of them can keep communicating with each other via channels. I can probably give you an example. Let me try to do that. So I've created a program here, and let me try running that program. Do I need to zoom this? Can people in the back see? Switch to light mode? I think this might be a good idea. Is this better? Awesome, thank you. Oops. Cool. let me try running a simple Go program which has some sort of Go routines, right? And to show you what I'm actually doing, let me zoom this. I'm going to be running this program, simple.go. Let me again switch this to light mode. Visible? Till the back? Okay. Pretty simple program, pretty simple program. We'll start with words. So there's a main function which has variable words, and there are a bunch of these words. And what we are going to do is we are going to just call a function, which is like we are using the keyword go, which is used to denote that we are turning this into a Go routine, right? As simple as that. You don't have to write a lot of boilerplate. People who have worked with threads in Python, you know how much boilerplate you need to add, right? You need to create a whole import threading and then threading, sync, all those. We don't need to do that, right? It's just go and the function name. Any normal function, add go in front of it, it will execute as a Go routine, as a parallel thread, right? And then we have written print words, right? So what does print on my mind do? It just takes whatever word we have and it just adds this word and just prints on my mind, right? Actually, it does not do the adding. It, you print the words using this function every 3 seconds. So print words will every 3 seconds print a word, and every 3 seconds print on my mind will just print on my mind, right? Let's see how this runs. Cats on my mind, okay. On my mind, food. Interesting, note this. Sleep on my mind, how many? No one? That's good. Goodies on my mind. Goodies and anyone? Yes, one. And then there's this kya bolti kya cheez hai paisa, which basically means what is money, right? So, yeah, slightly money-minded. But anyway, you see the output, the way it came out, right? Not really what we wanted, not really what we expected, right? Word and then print on my mind, word, print on my mind, right? That did not happen, right? So what does this tell us? This tells us that Go routines actually execute fully parallelly. There's nothing happening between them, right? At this point, they are not coordinating. Rather, you could say that, right? They are not coordinating. They are not talking to each other. One is like, I will print on my mind. The other is like, I'll print the words. And both of them are playing, right? And it's not making a lot of sense to us. So how do we solve this? The way we solve this is using channels, right? Let me try to open the other file, which is like waiting for the other guy to complete. And there's this signal which is being passed. And this is the channel which we are working with. So if you see here, we have created a variable called done. And what is this done? It is creating a channel. And it's a kind of struct. It could hold anything. The main thing is that we have declared it as a channel, right? Now in this done channel, whenever there is data in the done channel, only then will this function execute, print on my mind, right? So what is print words doing now? Initially print words was every 3 seconds, it was just printing one of the words. But now what it's doing is that every 3 seconds, it does print a word, yes, if you see this word plus some space. But then it also sends some data into the done channel, right? It's not sending true or false. No, it's not sending a count. It's sending a blank, a null value, but it's sending some value in that channel, right? And what is our print on my mind doing? Whenever there is any data received in the done channel, then it will print on my mind and it will wait for 3 seconds. If there is no data in the done channel, it will not print. It will wait for it. It will keep waiting for data to come into the channel. And let's see how it works now. Cats on my mind, that came correct. Food on my mind, that came correct, right? So now we have the order which we wanted to maintain. On my mind should only be printed when the word has already been printed. You understand that? Right? So think about this. A road construction is going on and you need to, put the road there, right? The folks who are coming to put in the road, if no one has put in the foundation of it, where do you put the road? right? So someone needs to put the foundation first, and only then you put the tar and all that, and you bring on the big machines to do that. Also, we have exhausted the words. So this is going on because after getting the channel variable, we have actually set it to print every 3 times, right? So that's what's happening right here. Anyway, let me stop this. So channels can help the threads communicate, and using basically a wait operation, it's very easy to do that. Let's move forward. And yeah, now we will talk about mimicking cognition. Now this is interesting, right? Mimicking cognition, how do you do that? Think about this, right? How do we function? How do humans function, right? And we are going to leverage both the concepts that we talked about, Goroutines and channels. But for now, let's just think about how a human works. We have all these senses, right? As I mentioned, you can hear people, you can see people, and you can probably even touch objects around you and understand what they are. They could be anything. All these senses we have, do we use them one at a time? Right? We don't use them one at a time. Probably some of our friends do, right? They're always speaking, not listening. But then we don't use them one at a time, right? That is the general idea, that while you are speaking, you can also listen to people. You can also look at people. And then there's a memory associated somewhere. Our mind, where we store things, where we remember things. There's a memory associated. And then there's some thought process. Whatever senses are doing does not necessarily get stopped by whatever thought process is doing. Right? You meet an old relative, you're like, so glad to meet you. Right? But what are you actually thinking? Why? Why again? Right? Never again. This should not happen again. You're trying to avoid that place from then on. Right? So this is what happens. Our thought process can be very much parallel to what our senses are doing. Right? We are smiling, we are giving out a very big smile, very glad to meet you. Please die soon. No. Yeah, let's not do that. But this is essentially what humans do. Do you agree? There are obviously more things. I have simplified this. You can probably be fighting with someone at some time without thinking about it actually. But let's keep that for later. This is essentially what we do, right, as humans. You have senses which are running parallel. You have a memory which could be running parallel. And then if you look at the arrows, it's always 2 ways. Sometimes you might have a sense and you might skip the thought process. You just react to it, right? For example, your stimuli. If you are writing with a pen on a table and your pen suddenly starts falling, you instantly try to grab it, right? There's really no lot of thought around it. You do not think about the last time your pen fell and what happened to it. That is not what we do. The pen is falling, catch it, right? So your senses could be replying sometimes. Sometimes you might use your memory for doing that. But if you start thinking about the last time your pen fell, it will already fall by that time, right? So let's not do that. Anyway, in our case, we are doing a slight change. The thought process, obviously, how do you make a computer think? For that, I have integrated. Do you know what this icon is? Gemini, yes. So I've used Gemini to run the thought process, to get a lot of input. We'll probably be getting a lot of input from some senses, and we'll be using Gemini to run the thought process, right? What do we understand from this input? What does this input tell us, right? So we'll be using Gemini, but then why do I have 4 dancing Geminis? Goroutines, right? If you notice people at the front, you're probably able to say this. It's a gopher, right? Which basically means we are going to use Goroutines, all of which will have connection from Gemini API to think, right? So we are actually creating a lot of thought workers. And just to make things easier for me, I've actually used GenKit, if you have heard of it. If you have not, then GenKit is like similar to LangChain. And if anyone has worked in LLMs, you have probably heard of LangChain, right? So you could use multiple multiple LLM API providers via GenKit, and you don't have to change your code. You can just keep adding whatever you want, and GenKit will handle it. If today you are using Gemini, tomorrow you want to use, let's say, Llama model, or maybe even OpenAI models, you can just change one connection string or a configuration string, and you are good to go to use the other model. So yes, we'll be using GenKit to maintain a single connection because 4 connections parallelly open to Gemini will lead you to um, rate limit errors very soon. So that said, yes, thought process done. GenKit is there. We have senses. What are these senses? These for a computer program, what could be senses? Right? Some sort of text input, some sort of visual input, converted to text. Right? Because computers really cannot understand image that way. So you will have to convert them to either text or numbers if you want to even go more below the layer. And anything else? Audio can be an input. Anyone worked on audio AI? By any chance, audio AI? No one? Yeah, for those of you who have, or maybe in future you might want to work with audio AI, audio is not an input to a computer, no. Audio is converted to digital signals. People who studied electronics in your engineering, ECE students, you know that audio is always converted to digital signals before being sent to a computer, right? So it's basically a string of numbers ranging from 0 to 255 most of the times, but otherwise you can go higher if you have a different sample rate. That said, yes, senses mostly text and images converted to text, and all of those converted to numbers, right? That is what our input is going to be. And then there will be some sort of memory. Now this memory, in my case, I'm going to be just using the RAM, not storing anything anywhere else. In your case, you could be storing it somewhere. And there could be a thought process. The thought process may or may not be directly involved in producing the response, right? So let's do a demo. I think we are pretty much on time. Let's do a demo. This is what we are going to do, right, for the next few minutes. DevFest Chennai presents Kaun Banega Crorepati, which means who will become a millionaire. And I'll be running the show. Yes. So this is what you will be getting in money. So please don't expect less. 100 USD, I believe. Anyway, step 1, get a gopher. I need a volunteer. I need someone who is... Yes, come. You have been nominated the volunteer by your friends. Please join me on the stage. Lift this table. No. Right? So just stand here for a while. Yeah, the next thing we are going to do is set the mood, right? And for those of you who know this meme, this guy is telling music, right? But we are not going to have music, no. What I'm going to do is I'm going to set up my laptop. Sorry for raising the hopes so much. No, we are not going to have fancy music right now. I did that in Pune and the organizers were like, what are you doing? So let's not, let's do PNPM dev. Now, the demo which I'm going to present is actually very interesting. It's like a couple of code bases. There are at least 3 code bases involved. And I'm not going to be sharing with you all the code bases because they are not relevant to most of the things which you are going to understand, right? So there's a quiz on which I have already voted. The quiz is, which Chennai experience have you definitely had at least once? There are 4 options. Got caught in a traffic jam behind an elephant during a festival. Has this happened to anyone? No? Never? They don't have elephants here? Yeah. So, fought over whether Marina Beach or Elliot's Beach is the best spot to chill. Is this a problem? Yes? No? Confessions? Okay. Yeah, it's starting to come up. Anyway, so this question is actually for you to answer. Not my problem, whatever happens. I don't know the answer, by the way. By the way, who serves the best filter coffee? Best filter coffee? No? No one? Okay. Anyway, let's come back. So one of the code bases, yes, and this is the UI. On the left side, it's actually blank right now. I'll tell you what will happen. Right now, he has not said anything. The audience has really not said anything. That's just me voting randomly. But I'll tell you what will happen, right? When you have seen KBC, right? All of you have seen KBC. What happens in KBC? What is the theme like? When the question is asked, what happens then? timer. Let's forget the timer. Let's assume this is a 1 crore question, right? Let's forget the timer. The host prompts you, right? The host tries to confuse you, right? He is also playing with you. He is also playing in your team, out of your team. Yeah, you don't really know what the host is up to, but the host tries to prompt you into providing an answer, right? If you say that, hey, I think this is the answer, he's like, maybe it is not, right? So this is what the host does. And right now we do not have a host. We will use Goroutines to create that host, okay? Now the host's job is actually very interesting. The host is also supposed to hear to the person who is on the hot seat, and the host will also listen to the audience if the audience is doing a poll. Right? You have seen this option, right? Audience poll, right? So what we are going to do is we are going to involve some audience. And that basically means you all need to take out your phones. Right? So we are going to involve more gophers. This is basically all of you. Some have left. Yes, take out your phone and you can either scan that QR code or open that link. Hello. Let's start with a hello. I think that's hello guys. Welcome. The game is about to begin, so buckle up and get ready. Right? And depending on how you're voting, the person will actually change what he's saying. Right? So yeah, I think he started with the sweating thing. You can probably start off with just use any of the options. The poll is heating up like the Chennai sun. A lot of you have voted for the Chennai sand at noon. So, yeah, it's actually talking about that. Maybe you can just say that you are thinking about filter coffee, right? You're thinking about filter coffee. Thinking about filter coffee. Let's see what response we get from the host. Did the host die? Is he ghosting you? Yeah, let me just say hello again. I'm not really sure what happened. Oh, okay. There was some safety error. Yeah, Gemini keeps running into this. Sorry for that. Yes, we are going to just say, for example, I'll just going to type filter coffee. Right? Let's try to see if it confuses there. Test your sanity. Maybe you can just write, I'm thinking about a bird. Just write, I'm thinking about a bird. Yes? A bird, you say, fascinating choice. Let's focus on the question at hand. Which Chennai experience resonates with you, right? So the host is actually considering what you're saying. The host is also listening to what you guys are voting. And then he's producing a response, right? So this will actually keep going on. Thank you. You do not win anything, sorry. There's a, look at the votes, come on. It's like 25% everywhere. A resounding D, you all have voted for D, by the way. You can try voting for A. All of you can try changing your votes to A. Maybe that will change something. Yes, let's see what happens. Okay, change all of your votes to A. Every 10 seconds, the thing unfreezes and you can change your vote. Look, right now it's talking about traffic jams and filter coffee, right? So yeah, as you keep voting more for A, it will obviously turn the answer towards A and it will be like, okay, people really are worried about the elephants on the road. Yeah, right now it's sort of mixed, but anyway, let's stop this demo and let me go back to my slides. So yeah, now the time is for me to preach, right? For those of you who understand Tamil, this is what is going on. I'm going to preach. So let's come to the code which is actually important for you to understand, which is this, right? What exactly is going on? So if you see, I'll jump to the main part of the code. So there are 3 Firebase collections which I've created. User collection in which a volunteer was putting in messages. And then pings which were used by the Goroutines to produce responses. There were multiple Goroutines who were handling this. There was one Goroutine which was continuously listening to what you all were voting, right? If you see down here, monitor and respond, right? So what monitor and respond is doing, it's actually listening to what you all are voting for. It is taking the summary of the votes all the time, every 10 seconds actually. And then there's listen for new user messages. There's another Goroutine which is listening to what he was typing, and that was also parallel, right? So even if he was not typing anything, you were seeing responses coming on the screen. That was because of your votes, right? It was always also looking at your votes. And yeah, that was pretty much it. Continuously listening to his messages, continuously listening to your audience voting, not actually waiting for him to speak something before saying something, right? Not waiting for you to change your votes before saying something, right? So the host is always there in the game, whether you are voting or not voting. If there is one vote, it will use that, right? And if he's saying something, that will also be used. So that is what was going on all the time. It was continuously doing the monitor and respond stuff. And finally, there was a generate response, which was like, I've given it some prompt. I think I can probably do a word wrap on this. So it's like, you are Amitabh Bachchan, you are hosting Convener, but the current status of user state is this. Respond in Amitabh style, max 30 words. All the messages were small. And then there's a conversation summary. So if he has said something in the past, that was also used. You see, he was continuously taunting the filter coffee thing. That was because he has, in the past, he has said about filter coffee. And then the user's current message as well. So the history is maintained. The history is used to produce a response. What you guys are voting for, that is used to produce a response. And what he's saying now will also be considered in the most prime. So yes, this said, and we are kind of done. Happy? Yeah. So these are some resources which you can go and explore to create something similar. You don't have to take a photo of this, no. I'll tell you when to take a photo. And that will be the one which will give you the entire slide deck. Right? So this is it. Yes, you can probably connect with me. I have the same handle everywhere. If you know a social media site, I have a handle there. Right? So something like that. Or you can simply Google Experian that. And finally, you can take a photo of this. This will give you the entire slide deck with all the links. The design might be slightly different because I use the memes and all in the talk, but I keep a sanitized deck. So you will get the sanitized deck in this. You will not have memes in it, but you will have all the links. So that was all. Thank you.